and he was working at J Wars. Donald is going to tell us about an implementation project that he worked on for our current release of VA Smalltalk. Donald.
Thank you. Can you all hear me okay? Good. I'm going to roll through these slides and then we'll have an exciting demo. Okay, let's see where the page down button is. Page down. Okay, so why are time zones important? Well, if you want to do duration calculations across daylight savings time transitions, if you have a payroll application, they can be wrong without daylight savings time info. If you're timestamping database records, say with the offset from UTC, which is actually called Coordinated Universal Time, and it's what used to be called GMT, they'll be wrong without time zone data. Because, for instance, New York is UTC -5 in the winter, but it's -4 when DST is in effect. Time zones also allow you to ask questions like, what time is it now in Moscow? And then the time zone data also tracks historical offsets. For instance, here, Hawaii was UTC -9:30 till 1947, and now it's UTC, that's wrong, it's UTC 10. Damn. Error on my first slide. Okay, so a short history of time zones. Railroads made them happen. They were codified in the 1800s, and daylight savings time was first used by the Germans in World War II. The idea was to save coal. It's not really clear that it does save energy. So since we have 24 hours in the day and 360 degrees in the Earth, a perfect world, each time zone would be 15 degrees of longitude. But since time zones are political, there are things like China, which since the revolution has 9 perfect time zones, but only one time in all those, it's the same time in all zones. Must be pretty weird. Places like Newfoundland, standard time, are 3.5 hours offset from UTC. Nepal is 5:45, and as I say, Hawaii has changed its offset. That's the wrong way. Okay. DST is, again, more stuff that DST is political. Arizona and Hawaii never go on DST, so right now it's the same time as it is Pacific Daylight Time. Congress changes DST whenever it feels like it. In 2007, it changed from, I think, used to be the first Sunday in April, and now it's the second Sunday in March that it goes on, and then they push when it goes off, which used to be the second Sunday in October. It's now out towards Halloween. It's not clear that it saves energy, but farmers just like it. Places like golf courses like it because you can go play around in golf after work. Okay, so where does the time zone data come from? Well, it comes from, it's now supported by IANA, the Internet Assignment, I forget what it is, but it's the time zone database. It's also called the Olson database after the guy who first did it. His name was Arthur David Olson. He was an employee of the National Institutes of Health. So I guess once you get done with curing cancer, he decided to work on time zones. But so it's known as zone info. It's on most Unix systems, and a time zone is really any region where the local clocks have pretty much agreed since 1970. Time zones have names of the form, some area, and then if it's, for instance, America would be the biggest city in the Eastern time zone, so that would be New York. Or Pacific would be Fiji, because that's the island. The zone info data you get as a series of text files, which are updated, I'd say 3 or 4 times a year. You download them, and then you compile them into a platform-independent binary format. These text files not only have DST transition rules and changes to time zone offsets, they also have leap seconds. So if you want to have scientific accuracy, there's been something like 7 or 8 leap seconds added since 1970. You can compile them and you can get scientific accuracy. Okay. So on Linux platforms, zone info ships with most OSs, but it lives in different places. Linux, it's off user share, AIX, it's user share lib, and Solaris, it's also user share lib. And the directory structure shows you the names of the files. So under America, you have New York, Chicago, Pacific, Guam, and it's just a layered directory structure. IBM, in its infinite wisdom, used a non-standard time zone format before 6.1, which caused a little bit of problems for me. Okay, Windows, of course, does it differently. It does not have any historical knowledge. It has just the last two time zone transitions. And of course, it also uses non-standard names, America, New York, and zone info. Windows calls Eastern New York. Since Windows does not support historical zone info, we ship the latest zone info data with our Windows product in each release. I'd also provided instructions if you need the latest and greatest. It's not that difficult to compile your own. Okay, other small talks, don't hold me to this. This was a quick look. VW seems to do the same thing as Windows. It has the last two transitions. It doesn't have it doesn't have any historical info. Faro has some time zones, pretty limited. Doesn't have any DST info. Dolphin, none in stock image, and Gemstone, I believe, uses zone info. Wow, I got that right. Good. Okay, so where to go look for a harvest upscale. So I looked at Alan Lovejoy's Chronos date time library. It's a huge package. He's got a really interesting site, but it's a lot of code. It's not just date and time, it's calendars, it's got Mayan calendars, it's got everything. So there was just too much too much there. I looked at the ICU stuff. Again, that was too big. It had a lot of calendar stuff, needed a lot of external files. And then I found David T. Lewis's Squeak package. It's just a small Squeak module he wrote, I don't know, 10 years ago. And it does only time zones, lots of tests, and it supports leap seconds. So I used that as a model for what I did. Okay, so the implementation, we have an ES time zone database class, and he's the guy who's kind of the manager. On startup, he sets the default time zone and default location by asking the OS, what's your time zone. He also knows how to read the binary zone info data from disk, and then for a little speed, he caches the recently used time zones, just so he doesn't have to go back to disk. And it's also got a Windows to Olsen key mapping so that Eastern Standard Time becomes American New York. Implementation, okay, our old date and time class had two instance variables. We had milliseconds and offset. So with the new date and time class, we replaced offset with a time zone object, which is an instance of ES time zone, which we'll talk about right now. So ES time zone has two instance variables, a time zone rule, which is the daylight savings time transition rule that is currently in effect. So the one we have now is the one that happened on March 12th, I think. And then we have a time zone rule set, which is actually a copy of the entire American New York file that we keep around for efficiency. Found out from one of our users that this isn't really a great idea because it makes the date and time class kind of heavy. We're looking at lightening that up. But you can see the time zone rule has a transition time and number of seconds, and then it says what should the offset seconds be set to when this transition time occurs. It has an abbreviation. The last two things there in purple are not used. Your time zone rule set, again, has the name of the time zone, POSIX string, and then the transition timetable has all the time zone rules for that time zone. And that's what makes it kind of a heavy instance variable. So here's our time zone rule set. I just went through this. This is American New York. Its abbreviation is LNT, which I guess is more standard than EST and EDT. The time zone rule, as I said, has got the transition time, whether it's DST or not, and one of the abbreviations. So, what you can't do with zone info data, you can't go from an abbreviation to a time zone because there are duplicates. For instance, EST is not only Eastern Standard Time, it's also Eastern Summer Time in Australia. So you just can't do it. You also can't go from offset to time zone name because, for instance, America, New York is UTC -5 in the winter, but it's also America, Chicago when DST is in effect in the summer. So you just can't do it. You got to have the time. You got to know what the time zone name is or get the data. So the other thing that makes this stuff interesting is the time zone. The time zone files don't know their name internally. I asked in the mailing list why. I got an answer from Martha David Olson, but I can't say I understood it. Okay, so how are we going to set the system time on Windows? Well, we're going to ask the registry, and where I live, it's going to reply Eastern New York. So then we'll look it up in this class variable platform Olson keys table, and we'll find out that that is America, New York. We'll go read the binary zone info data, and then we'll create an instance of time zone, ES time zone rule set from it, and we'll put that instance in the database singleton variable default time zone and set the default location to America, New York. And this just shows what the platform Olson keys table looks like. There's about 283 things in it. Okay, on Linux, Linux is a little more complicated. etc time zone should have a valid Olson name, but it doesn't have to. And if you change the Olson name in that file and then save it, it does not change the system time zone. But if you go through the GUI and change the time zone, this will reflect it. So we can't rely on that. But we don't really need the name because on Linux, etc local time is a binary copy of the current time zone. So all I do is go get that etc local time, and I create an instance of ES time zone rule set and set my defaults. But we call it etc local time because we don't really know what its name is. But we don't need to. Okay, Solaris. Again, this is a binary copy. This should be a binary copy, but the file doesn't know its name. We'll go ahead and read it, and this is basically the same as what we do on Linux. It's just that we get the binary copy from a different place. And then AIX. AIX does not have a binary copy of the system zone info file. In the text file etc environment, there's a line that starts with TZ equals. So you read that, you get the name, and then you go look it up in zone info and set everything. And this was difficult. So what can go wrong? Well, maybe you have a bad path to zone info. Maybe the binary zone data is just not there, or maybe the named time zone from AIX is just missing. So what are you going to do? Well, we know the system offset, so just to keep everything running, what we'll do is we'll create a fake time zone. So if we have an offset, say of -5, we'll create a dummy time zone of TZ -05, and we'll put one time zone rule in it saying that DST is off as of the beginning of the century, and there will be no DST transitions. But everything else in date and time will work anyway. So you can give me any offset you want, and date and time will continue to work. And of course, we use log4s to tell people what we're doing if they want to turn it on. Okay, deprecated APIs. Obviously, as I said before, you can't get to time zones from offset. So the ANSI APIs that specify offset, we create a dummy time zone object, as I talked about on the previous page, and keep on going. Everything works fine, but you don't get any DST transitions. Okay, optimization. We all know premature optimization is the root of all evil, so I waited until the end, dropped the VAST profiler on it, and found out that supporting leap seconds made everything too slow because there were being conversions done into this intermediate object called point in time, and then back and forth. And so we decided we're not going to support leap seconds. We tossed it overboard since we don't. Business time is pretty much good enough for everybody. So the date and out time constructor method with time zone support was just 1 millisecond slower than previous implementations. And as I said before, the ES Timezone database Singleton has a couple of caches. So before he goes to disk and looks for America, New York, he looks in the cache and figures out if he already has it. But again, I didn't put that in the beginning. I waited to see what I need to do and added the optimization at the end. Okay, so we got 100 S-unit tests. So one of the things you want to test for is edge cases. So for instance, on the Sunday morning at 2 o'clock when DST came into, when DST started, 2 o'clock immediately became 3 o'clock. So there is no valid time, 2:01 a.m. on that Sunday morning. It doesn't exist. So you have to catch that. And again, adding a duration of 10 minutes to 1:59 right before DST starts should throw an error because there's no such time as 2:09. So we catch those. So what went wrong? Well, so testing went fine, but a week after release, a German user found that Timezone data could not be found on Windows 7 or XP. And our function called getOS Timezone name returned Mittel, I'm going to mess this up, instead of Europe Berlin. I was stunned. I read everything I could on time zones. I scanned the Timezone mailing list, and I had no idea that that Windows. I mean, I knew Windows presented the German time zone in the German name, but I thought fundamentally it was using things like Eastern or Europe Berlin down below, and I was wrong. So, fortunately, I have a boss who's seen people screw up before. Thanks, Mike. Okay, so if I had to do over again, I would get a pre-release out to select non-English customers just to find this stuff, because it only took about less than a week to fix, but I had no idea. I'd get after the platform differences sooner. Getting it working on AIX was, and then the other thing that was difficult is that date and time is really in our kernel, right in our kernel hierarchy. So we had to do some fairly significant changes to our packaging rules to make sure everything got packaged in the right order and things got initialized in our startup code in the right order. And as always, leaving more time for things to go wrong. Okay, well, we'll have a demo here in just a minute, but I want to tell you a joke. So this elderly couple is sitting one night watching TV, and the guy gets up and says, "I'm going to get some ice cream. You want some?" His wife says, "Yeah, I want some chocolate sauce on mine." He goes, "Okay." She said, "You need to write that down because you got a bad memory." He goes, No, I'll remember. And I want some nuts too." "Okay." He comes back 20 minutes later with a plate of bacon and eggs. She looks at him and says, "Where's my toast?" Just want to see if you guys are awake. Now, instead of a demo, we're going to have before the demo, we're going to have a little surprise. And the surprise is that we have outsourced the log4s logging framework that we released.
Open source.
Opens. What? What's wrong with that?
Chart's right.
You said
the words were wrong.
Okay. Anyway, it's in the public domain under an MIT license at SSH Gemstone. This was our port of log4j, and it runs on Pharaoh 2.0. So check it out. Have a nice time. Let me know. Okay, so we'll have a demo here. Let's see. Just here are the references. Chronos.st.org is Alan Lovejoy's site. It's got some really interesting stuff. You can read about Olsen time zones on Wikipedia. And then at iana.org, time zones, you can get the time zone code and the latest compiler. There's not a hell of a lot of documentation about it. Most of the documentation is actually in the ZIC, in the compiler. You have to look at it. There's some decent examples, but it's not that intuitive. Okay, so let's see. Let's go over here. So here we have wrong image. Here is an image with no time zone information. So what we have here is we're going to we're going to calculate a duration across the DST transition. So we're going to start Saturday, March 8th at 8 o'clock and ask the duration to what looks like to be 24 hours later, which is 8 o'clock Sunday. Well, so what you get here is you get a duration of 86,400 seconds or 24 hours, but that's wrong. It's really 23. So if we do the same thing with time zones, we will get, that's not right. I love Delos. 256. That's wild. Okay, let's go on to the next one. All right, so let's look at the offset of Hawaii in 1943, and whoops, didn't work very well. And we can see that he's 10. You sure this image has got time zones in it? Let's see, let's find that. This works on my machine. This is Seth's machine. All right. Okay, this one works here. You see, we have the offset. We have the time zone, and the time zone rule set is age of Kathmandu, and the offset over here is plus 545, and it's also tomorrow. So the time zone is new, but we changed the offset, and he knows that we're already on the 13th. And then we can see just here that in Newfoundland, this is UTC minus 230. In fact, I was in Canada last week and listening to CBC radio, and they'll say it's 3 o'clock, 2:30 in Newfoundland, like on the radio. So here you can see that we have a time zone of America St. John's. Their abbreviation is NDT. I don't know what that means, but we have an offset of minus 230. And then finally, we'll look at one that has Pacific Chatham. There's some islands out in the Pacific. I'm not really sure where. Oops. My day. Okay, you're going to have to take my word for it. It's 5:45. That's all I got. Anybody questions? It was an interesting thing to do, but there were a lot of challenges. It was an interesting area, but like I say, there were some challenges, mostly in the cross-platform stuff. Okay, thank you very much.